First, you poured 3/4 of a cup of water into an empty bowl. Then you scoop out 1/3 of a cup of water. How much water is left in the bowl? Make math drawings to help you solve this problem. Explain your answer, attending carefully to the unit amount that each fraction is of. And part B, in solving the problem, how do 3/4 and 1/3 each appear as equivalent fractions? So if we make a math drawing, first identifying for ourselves what we imagine 1 cup to look like, we have the quantities 3/4 of a cup, and we have the quantity 1/3 of a cup. So using the least common multiple, we're going to use 12, the multiplication of the denominators. So the least common multiple between 3 and 4 is 12 itself. So our whole is going to be 12 boxes in size. And one of the easiest ways to do this would be to have a 3 by 4 representing the whole. Zoom out a little. So if we have a 3 by 4 array representing our whole, then it's easy to see what 1/3 should look like, and it's easy to see what 3/4 should look like. So we're going to start with the same sized whole, and to see the 3/4, right, we'll first cut our whole cup into fourths, and then we'll shade 3 of those so that we have the quantity 3/4 of a cup. Now we want to see what 1/3 of a cup looks like. So 1/3 of a cup we can shade in vertical rows. So now we have in our second image what 1/3 of a cup looks like. Now, one thing we're going to do is we're going to take the cut marks of the first image and put them onto the second, and we're going to take the cut marks from the second image and put them onto the first. And what we see as a result of this is now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 10, 11, 12 shaded. And this is still 9/12 of a cup. And now we have 1, 2, 3, 4 of our 12s of a cup shaded. And we're asked that if we put the first quantity into an empty bowl and remove the second quantity, how much of a cup would be left? How much water's left in the bowl? So we're going to subtract in our image and represent the end result using the same size whole. So we have a 3 by 4 array representing 1 cup. If we are subtracting the second quantity out of the first, then what we want to do is erase 1, 2, 3, 4 of these shaded boxes. So first, let's give ourselves 12 boxes that represent our whole. And what I find easiest to do is to physically remove them from position. So I'm not going to write any of these first three because I'm going to remove them. And then I'm going to remove one from the next column. And as a result, I have these two still. Out of my first image, I have those two still. And I have this one where I removed 1, 2, 3, 4 from our first image of 1, 2, 3, 4. The end result is 1, 2, 3, 4, 5. 5 out of 12 boxes are shaded, and the whole represents a cup. So 5/12 of a cup of water remain in the bowl. And if we use our traditional algorithm, where we subtract the numerators and divide by the same denominator, we end up with the same result of 5/12 of a cup. Now, part B asks us, if I can zoom out a little more. It reads, in solving the problem, how do 3/4 and 1/3 appear as equivalent fractions? Well, we can see here that one equivalency is shown in our first image, and one equivalency is shown in our second image. So the answer for part B is that 3/4 is equivalent to 9/12, and 1/3 is equivalent to 4/12. That's how we see equivalent fractions in this problem.